Hey guys, welcome to Coding Science. Today, we'll take a look at how the data structure is in a stack. First, we're going to see the variables and what kind of methods are associated with the stack. So let's get started. Okay, let's get started on the data structure of the stack. So to make a stack, and this will be something that we call a simple array stack. So what we need is to start is an array, something that we can, a container where we can keep the objects that we try to stack together. Now let's make an array. In this case, we'll work with integers. So this array that we call S will be an array of integers. But we also know, for those that have worked a bit with programming before, that simple arrays and normal arrays, they need to have a predefined size. They're not dynamic. They don't change size over time depending if there are more elements coming. It's just they have a specific number of cells where you can put stuff in, and they will stay that size. You don't need to fill them in, but you can never put more than what you define. So we will need also a variable that we will call n, that represents the size, the number of elements that you will allow in your array. I just want to make sure that people understand that this is not the index or the pointer. It's not the variable that will tell you in which cell you're going to go into the stack. This is just the number of cells. And this is for a specific reason, is because we can't use the same for both the pointer and the amount. Because let's say that you have an array with 10 cells, the n will be equal to 10. But as you must know, maybe, arrays have pointers from 0 up to the number n. So it means that you start at 0, and then the last index for the array would be then 9, not 10, 9. 10 is excluded. Because if you count the numbers of cells from 0 up to 9, you have 10 cells. So that's important to remember. So now this is just the size of the array, but we'll need it in the functions. You will see, both to start to initialize the array, but also because we're going to use some checks around it later. Now we also need a pointer that we'll call p. The pointer is also an integer. Both of them are integers. And this pointer will keep track of which element in the stack is the latest element inserted. So this one will be moving up and down depending if you push things or pop things. And we'll take a look at this closer later. As you can see, it's been initialized to -1. It's not the others haven't been initialized, they're just empty. But this one will be initialized at -1. It will always start, when you create your stack, it will always start at -1. And there is a specific reason for that, and I'll talk a little bit about that on the next step. So we have our variables. Next to that, what we need when we make a class, because this will actually become a class in a programming language, what we will need is a constructor. So this is not a constructor specific to any kind of class. I mean, most of them are written that way somehow, but this is just to represent what kind of information we will need in the constructor. So we can see here, for example, that we'll call this constructor stack with a big S. And it will take in what's in parentheses here is the parameters that are taking in. It will take in an integer, and it will be the number n. So when you initialize your stack, you will have to write either 10 or any kind of numbers that you wish to have to know the number of cells you want in your stack. The parameter, the constructor will not return anything, so we'll have a void here, and it needs to be public so that it can be accessed from outside of the class. And then we'll need some methods because we have to do stuff with our stack. So we'll have the first method, that is the push method. We've seen it earlier. The push method is to add objects to push objects in our stack. So since we're working with integers here, this one will take also in integers. And it will be called, the variable will be called O. If you were making a stack of other kind of objects, this int here would be replaced by something else. But today in our example, we'll use integers. The function or the method, is not going to return anything. So here we'll have void also. Void means that it does not return anything. There is no result to get from that method, and it also needs to be public so we can access it from outside of the class. The next function that we have here is the pop function. It's the two main functions of the stack. Pop here, as you can see, has no parameters because pop is to retrieve the latest inserted element. You can't choose what you're going to pop. It will always be the latest inserted element. But since we are retrieving something this time, we'll have an int here because we are working with integers. So we'll retrieve the latest int that has been inserted in the stack. And it also has to be public because we want to access it from outside the class. Now, there is another function that is interesting. It's very similar to pop. It's called peek. Now, peek, to understand it, it's the same as pop, but it's like a box and there is something in it. Pop, you would open the box, take it out, and see what it is. Then the object would be in your hand. You would see what it is, but it's out of the box. Now, peek is exactly what it does. You would open the box, look at it, see what it is, but you don't remove it from the box. So that's pretty much what we're doing. With peek, we are looking at the value, the latest inserted value, but we're not removing it from the stack. So we get an integer here, we'll get the integer, we'll get the value, but we'll not remove it from the stack. So if you do peek 3 times in a row, you get 3 times the same value in a row. And it also will be a public function. The next two functions we'll see, they are kind of check functions. So the first one is empty. This one will be returning a Boolean value. For those that don't know, a Boolean value is a 0 or a 1 or a false or a true. So we use 1 for true and 0 for false. And the function is empty, then will return you true if your stack is completely empty. So here it means if p, we'll talk a little bit more in the example why, but if p is -1, so if p is empty, if the stack has no object in it, then it will give you the true value true or 1. Now, if there is even one element in your stack, the isEmpty function will give you false or 0. The next function is kind of the opposite. It's the isFull function. So now its full function, it will give you true if there is no more space in your stack. We talked about that arrays, they're not flexible. If you get an array of 10 elements, there is 10 elements, you cannot put 11. Well, with that, and if you would try to put an 11th element, you would get an error, a crash, or it would get some trouble in your program. So the isFull function allows you to check if you have more space. And so if there is no more space, it will give you a true, so a 1. But if if the stack is not full, if you still have at least one place available, one place that is empty, one box that is empty, then it will return you a false Boolean value, also 0, either 0. And also this one will be public. Well, that's it for the class structure of the stack. If you're interested to learn more, I also have a video on the concept as well as on how to implement a pseudocode for the methods that we just seen. And I also have a full course containing all 3 videos if you want to know everything there is about the stack. I hope you enjoyed. Don't forget to like and subscribe if you want to see more. And see you next time.